Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept of moment of momentum equation. In our previous lecture, already we have discussed the concept of momentum equation and we have derived the equation for momentum equation. And based on that also, we have solved a problem on that. Now we'll see what is mean by moment of momentum equation. If you have seen the previous video, we can understand what is momentum and what is momentum equation we have derived. Now, first, let me remind you that momentum equation, what we have discussed. Actually, momentum equation is, we know that the force applied to a body, or to a fluid, not body, to a fluid, and that will be equal to the rate of change of momentum. Okay. So now, in this momentum equation will derive from the momentum principle or conservation of momentum. So this momentum equation is derived from the principle which states that the resulting torque, which is acting on a rotating fluid, is equal to the rate of change of momentum equation. So rate of the torque equal to the rate of change of momentum equation. Okay. Momentum equation. I just written in the short form. Yeah. This is the definition of this momentum equation. Now, first things, let me tell you where it can be applied. The concept of momentum equation will be applied in several areas in the fluid mechanics. Now, if you ask me, what is the practical example of this? First one, I'll give a sprinkler example. Okay. First one, I'll give an example of sprinkler. Suppose if you have seen the sprinkler, like there will be a pipe will be there here, and through this we used to connect that sprinkler here, and mostly it used to use for our gardening purpose. And now this kind of we have the pipes are there, and through which the water will be supposed to be goes out. The water will be supposed to come inside here, okay, and it used to goes out from this. Now, if you see, this is the position of this pipe through which the water is coming in, and the point which is where it is going out. If you consider this distance, okay, and we can consider some distance of length L1 or L2. Now, if it is there like this, you can keep a length of that. Now, if you started rotating this one, then in that condition, you can consider this is a R1, and this one we can consider R2 here. Okay. The distance R1 and R2 I have taken from this center point of this. Center point in the sense from this middle of the point where it's the water is coming inside. Now, if you see the velocity of here, we can get V1 here, and the velocity of the fluid we can take V2 here. Okay. Now, as I told you that the momentum equation, that is defined as the torque which is equal to the resulting torque, which is equal to the rate of change of momentum equation. Okay, or momentum we can write equation on it right here. Only momentum we can write. Momentum equation we are going to derive. Okay. Now, for this condition, this is one example I have given you. Okay. Apart from that, also we can use this concept in the turbine, which we have not discussed till now, which is there in the hydraulic machinery, turbines, or we can use in the pumps, and also you can use in the gyroscope also, like where you can get some angular rotation type is there. There we can use this concept. Okay, there is a angular rotation will be there. Suppose the point of the fluid which we started from here, and the fluid is started rotating. The fluid is started rotating in this like this. Now there we can use this momentum equation. And one more thing, this concept also called as angular momentum also. This is also called as angular momentum. Okay, so let's start the derivation for this without any delay. Now here what I'll consider, let me consider this is, when the fluid is coming in and it is distributed in two different areas. Let me consider this is section 1 and this is section 2, suppose. Okay. Now at this section 1, we can write what is the velocity of the fluid, at section 1, and what is the R1, as I told you, the radius of the, this is the radius of the curvature, you can say, or the distance from the center point to here. Okay, so that is the radius or curvature of section 1. Similarly, in section 2, also you can write what is the velocity of the fluid and the distance or the radius of the curvature from the point to section up to the section 2. And here one more thing, what is the rate of fluid we need to be considered. That means what is the volume of fluid which is coming inside to that one, that is Q, and we need to consider the density of the fluid also, because these are the some density, the properties of the fluid, and this is rate of fluid or rate of flow of the fluid. Now if I want to write the momentum of the fluid, how is to calculate the momentum? Now we know that the momentum of the fluid equal to mass into velocity. Mass into velocity. This equation we already studied in our previous videos, so we know this one. That means to calculate the momentum of a fluid, like how it is acting or how it is rotating, so that need to be calculated what is the mass of the fluid and what is the velocity. Okay, so this one I can write here mass into velocity. So in the place of mass I can write, we know that density equal to mass by volume, so I can write here mass equal to rho into V. So this one I can write rho into V. V equal to velocity, sorry, here it is volume, here it is volume, and here it is velocity. Okay, now this is momentum of the fluid. Okay, and this one, now this term, okay, if like we can consider with respect to time, momentum with respect to time. So with respect to time, if you consider, then or you can say the rate of change of momentum, suppose, or the change of momentum. So rate of the change of momentum will be nothing but with respect to time we need to consider. So if you consider with respect to time, then here also you can consider with respect to time. That means the volume per time, volume per second. This is actually the volumetric flow. So that one we can write rho into, this is volumetric discharge or volumetric, like volume of fluid per unit time, how much it's moving. That is nothing but we can write Q, and this is V1 or V you can write. Okay, this is the, suppose we are section 1. Okay, let me consider this is for section 1, suppose. Okay, the momentum of fluid at section 1, then we can write there velocity 1. Okay, so this is V1. Okay, now for this condition, if I want to write the momentum equation, moment of momentum per second at section 1 per second at section 1 equal to, actually the momentum equation, actually that is the formula is nothing but the momentum equation. What is that momentum equation? Mass into velocity. Along with that we need to multiply, that means at what rate or what distance, not rate, at what distance it is rotating or it is moving. That means we can write here a radius of r. So we are taking for the section 1, so I can write here r1, or in place of r1 also we can mention, if you are considering that L1 length or some distance, so that also can be mentioned here. So here what I can write, rho q, this is v1 and r1. This is for the section 1. Similarly, the momentum per second of fluid at section 2 equal to, similarly I can write, rho q v1 r1, sorry, v2 r2, because at section 2 we have taken already v2 and r2. Now this is the momentum equation per second of fluid. Okay, like how it is rotating here from this point. Okay, now if I want to write again, because I need to satisfy this this definition of this momentum equation, that is the resulting torque, like how the fluid is rotating. Okay, the torque equal to the rate of change of momentum. So now what I'll write, that is the rate of change of moment of momentum. What is the value for that? So this one we can write nothing but like what is the changes happened in this position. That means what is the momentum at the section 2 and what is the momentum at the section 1, the difference between these two. So what we can write, that is rho q v2 r2 minus rho q v1, and this is r1. So we can take common of this rho q, because density and fluid, see, density of the fluid and the discharge or the rate of flow, both will be, this is constant, you can take it out. So here what we can write, v2 r2 minus v1 r1. This is nothing but we can write T. As for our definition, we can write T equal to the resulting torque equal to the rate of change of momentum. So this equation is known as momentum equation. Okay, and this equation, as I told you, like we can apply in different places in the practical application. Along with that, for any kind of flow problems, okay, for any kind of analytical flow problems, also like in case of turbine or centrifugal pump, okay, there if you see the fluid will be rotated, it will be coming inside to the pump. Okay, and to find, as I told you, to find the torque of water which is exerted by the water and the sprinkler. So this concept will be used in different places in our practical application. So I hope you understand this concept of this momentum equation. Still, if you are having any doubt, you can give a comment on the comment box. Thank you all.